Geometric reflections are when you have a figure and you flip it over a certain line. So we'll start with just a coordinate plane where we have the x-axis, the y-axis, and then I want to show you the line y equals x. So the line y equals x, that just means it's all the points where x and y are the same. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and then the negatives of those, including 0, 0, negative 1, negative, and so on. So if I connect these points, this is the line y equals x. Likewise, you can also have the line y equals negative x. It's the same diagonal line, it's just going in the opposite direction. So this would be the line y equals negative x. So these four lines, the y-axis, the x-axis, the line y equals x, and the line y equals negative x, these are the four lines that are most often used when you're reflecting a figure. I've got this triangle here, and if I want to reflect this over the y-axis, that simply means that each point is going to be flipped to the other side of the y-axis. So at this point, which is negative 2, 4, that would actually become the point positive 2, 4. And the same thing would happen for each of these other points. It's just going to flip to the other side of the y-axis. So this is the point negative 3, 1. It's going to become the point positive 3, 1. And the same with this one. So there is a coordinate rule for a reflection over the y-axis. So let's look at our points and see exactly what happened. So we started with the point negative 2, 4. That was this point here. That point became the point positive 2, 4. Then we had the point negative 3, 1. And that became the point positive 3, 1. And the point negative 5, 4 became the point positive 5, 4. So if we look at these transformations, how this point was changed to this one, the only thing that changed was instead of having a negative x value, it became a positive. So instead of negative 2, we had positive 2. Instead of negative 3, it's positive 3. So the only thing that changed was the sign of the x coordinate. So whatever point you start with, the sign of the x changes. Now let's look at a reflection over the x-axis. So you could probably guess that this is very similar to reflection over the y-axis. So it's essentially the same process. The points are now being flipped over the x-axis. So at this point, negative 3, 1, we now put that point on the opposite side of the x-axis. So that would be the point negative 3, negative 1. And we repeat that process for each of the other points. So negative 2, 4 becomes negative 2, negative 4. And negative 5, 4 becomes negative 5, negative 4. So let's look at what our rule would be for a reflection over the x-axis. All right, we started with the point negative 3, 1. and that became the point -3, -1. With the point -2, 4, that became the point -2, -4. And with the point -5, 4, that became the point -5, -4. So now we can see that our x value stayed the same, but the y values became opposite signs. When you have a reflection over the x-axis, the original point you started with, xy, becomes the point x and the opposite sign of that y value. With the reflection over the line y equals x, we really have to think about what it means for y to be equal to x. I've already written out our points for this triangle, and we're going to look at what happens if your y value is your x value. In other words, if you're reflecting over the line y equals x, then your y value that you started with, so if y is equal to x, then y in your original point becomes your x value in the new point. And if y is equal to x, so that tells me this y becomes my x value. And vice versa. X is equal to y. So my x value, which was 3, now becomes my y value. So really all that's happening is the x's and y's are switching places. So when we graph these, I'm going to show you what this looks like on the graph and another way that you can think about it if you need to see it visually occurring. Okay, so this point, -3, 1, if I were to take this point and go straight down to the line y equals x, how many units did I go down? I went down 1, 2, 3, 4 units. Now I'm going to go to the right 4 units, and that's my new point. Same thing is going to occur with the other points. From here, we're going to go down to the line. Then we're going to go right that many points. So we went down 1, 2, 3, 4, 5, 6. So we're going to go right 6. 1, 2, 3, 4, 5, 6. And the last one. We went down 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to go right 9. So when you have a reflection over the line y equals x, your x and y values switch places. So if you have your point x comma y, then you would just take those numbers, whatever they are, and switch their places. Okay, let's say we have the line y equals -x, and we want to reflect this triangle over it. Then we're going to use the same process that we did for the line y equals x. So you can take a point, find the horizontal or the vertical distance. It doesn't matter which way you go. But you're going to take that point, draw a line or count over to the line y equals -x, and then go, if I'm going to the left, then I would need to go down that many. So 1, 2, 3, 4, and then down 1, 2, 3, 4. And we'll repeat that process for each point. Now notice if I had gone down first, then I would be going down 1, 2, 3, 4, and I'd go left 1, 2, 3, 4, and I'd end up at the same point. Okay, so let's see. If I go down from the next point, 1, 2, 3, 4, 5, then I'd go left 1, 2, 3, 4, 5, and we'll repeat that process. From the top point, I'll go left first, 1, 2, 3, 4, 5, 6, 7, and go down 7. 1, 2, 3, 4, 5, 6, 7. Now notice that when I create this triangle, it looks like it's just been flipped over this line, so that if I were to fold this graph with the crease where this line is, y equals negative x, if I were to fold this over, then these points would line up with each other. Alright, so let's look at what the coordinate rule would be for this transformation. So with our point 4, 1, so that was this point here, this point became the point -1, -4. Okay, for the point 3, 4, this one became the point -4, -3. And finally, for the point 1, 3, that became the point -3, -1. So if you have a figure and you reflect it over the line y equals negative x, whatever you started with as your point xy, notice that not only did my points switch, so 4, 1 became -1, -4, so they switched places and they both got the opposite sign.